Topics in Math Notes 1.2 Part 2, Properties of Rational Exponents. All right, page 18. These can be found in your textbook, just some different properties of exponents. We've been learning quite a few throughout the year here, or trimester anyway. All right, so we had some review last week too, so hopefully that'll prep you for a little bit of this. All right, let's go look at number 1 here. Simplify. What is the square root of 125 plus the square root of 45? So these are perfect squares. What you want to do is think of all the list of perfect squares. So we have 1 times 1. That's not really going to help us simplify. So we have 2 times 2, 3 times 3, 9, 4 times 4. So 16, 25, 36, 49, 64, and so on. Okay, so which of those perfect squares goes into 125? So we can break that apart to be the square root of 25 and the square root of 5. Okay, which one goes into 45? We've got square root of 9 and square root of 5. So what is the square root of 25? It's just going to be 5. So 5 times the square root of 5 plus, and then the square root of 9 is 3 times the square root of 5. Finally, you can add these up. It's like you have 5 square root of 5s and 3 more of them. So we have 8 times the square root of 5. Okay, number 2. This one's similar, but it's the 4th root this time. So 1 times 1 times 1 times 1, and 2 times 2 times 2 times 2. That'd be 16. 3 times 3 times 3 times 3 would be 81, and so on. Okay, so 81 is a perfect 4th root. So we can think about breaking this apart. What is the 4th root of 81? What is the 4th root of x to the 8th? What is the 4th root of y to the 4th? So the 4th root of 81, what times itself 4 times is 81? Was just 3. 4th root of x to the 8th. The shortcut way, you can divide the exponent by the root, by the index number there. But really it's thinking, how many x to the 4ths can I pull out? I can pull out 1. That'd leave me with 4 of them, so I can pull out 4 more. So you can pull out a total of 2 x's, so x squared. Okay, the 4th root of y to the 4th will just be y. So your answer is just 3x squared y. All right, number 3. So you can either multiply these as it shows above. Otherwise, I'm going to focus on the inside first. What is the square root of 64x to the 8th? Square root of 64 is 8. Square root of x to the 8th would be x to the 4th. So if we continue on, what times what is 8? Cubed root of 8 is a perfect cube. So we can simplify that to be 2. And then we're left with the cubed root of x to the 4th, which the cubed root, we can pull out an x. So we can rewrite it. I'm going to rewrite it for a minute here. We can think of it as the cubed root of x to the 3rd, and we still have x to the 1st left over to get 4 of them. So I can rewrite this as 2x times the cubed root of x. Okay, so the first 3 examples, we are given radicals, and we wanted to simplify the radical. These 3 examples were given fraction exponents, but we still want to simplify them. And then I'm going to show how to write them as fraction exponents for the answers or radicals. So we used our same exponent rule. So think if this was x to the 1st times, or a to the 1st times a to the 7th, we would just add those exponents. Same thing here. A to the 1/3 and a to the 7/3, you're just going to add those. So it's going to become a to the 1/3 plus 7/3. So it becomes a to the 8/3. So if the directions said write your answer as rational exponents, we would be done. If the question said write your answer as a radical, we've got a little bit more work to do here. So first I'm going to think of it, that number on the bottom, remember that's the root, the index, and so it's the cubed root of a to the 8th. So now we think, how many a's can I pull out in front? So every group of 3 a's, we can pull 1 out in front. Okay, so we can pull out 2 a's, so a squared, and you would be left with 2 of them. Okay, another way I think about this is, think about doing long division. How many times does 3 go into 8? Twice. Minus 6 is 2. So it's like 2 remainder 2. So we go, I can pull out 2 a squareds, but I'm left with 2 underneath. So a squared times the cubed root of my remainder, a squared. Okay? All right, let's look at number 5. A to the 2/5 times a to the 7/5 over a to the 3/5. So let's first multiply the tops. So we're going to add the exponents since we're multiplying those a's there. So a to the 2/5 times a to the 7/5 would just be a to the 9/5. Okay, so over a to the 3/5. So we're going to continue simplifying. So now, if I had a to the 9th over a to the 3rd, we're just going to subtract those exponents to make it a to the 6th. So a to the 9/5 over a to the 3/5, we're going to write it a to the 9/5 minus 3/5. So we can simplify it. If it asks for rational exponents, we can just write our answer a to the 6/5. If it asks us to put it back into radical form, our index would be 5, so it's the 5th root of a to the 6th. So now I can pull an a out front. A times the 5th root, we're left over with 1. A times the 5th root of a. Either of those would work. All right, number 6. So you want to apply, since there's no addition or subtraction sign, you want to apply the exponent to each variable or value. So we're going to have 2 to the 3 over 2 power, a to the 3rd to the 3/2 power, and b to the 4th to the 3/2 power. Okay. So for that 2, let's just leave it that way for a little bit, and we may adjust it here in a little bit. So for the variables, think of that as over 1, so we can combine these exponents. So let's just leave it 2 to the 3/2 power. And then we've got a to the, we multiply the tops, 3 times 3 is 9, 1 times 2 is 2. And then b, we've got 4 over 1, so 4 times 3 is 12, 1 times 2 is 2, 12 divided by 2 is 6, or you can corner reduce, b to the 6th. Okay, so since these, the 2 and the a both have fraction exponents, those are going to go under the square root, okay, because they're both over 2. But the b did not have a fraction exponent, so we're going to bring that out front. So we have b to the 6th times the square root of, and then we have 2 to the 3rd, a to the 9th. So since we have 2 to the 3rd, which would really be like 8, I can pull a 4 out. I can pull out 2 squared. So it's going to become b to the 6th times 2 times the square root of 2a to the 9th. And actually, we can pull out some of those a's too. So a to the 9th, since it's a square root, I can pull out a to the 4th, but we're left with 1. So if you like that long division example, you can think, how many times is 2, since it's a square root, going to 9? 4 with the remainder 1. So I can pull out 4 a's, so a to the 4th, and then remainder 1. There's 1 a left over. So if I was rewriting it, I might just put it in a different order there. 2a to the 4th, b to the 6th, times the square root of 2a. Okay, rationalizing the denominator. We skip forward to number 12 here. Eliminate the radical in the denominator by multiplying both the numerator and denominator by an appropriate expression. So what we want to do on this one, we want to get rid of that square root of 3. Well, what can I take it times to just get square root of 9, which is 3? We can take it times itself. Square root of 3 times square root of 3 would be 3. Do it to the numerator. So 2 times the square root of 3, all over 3. Okay, number 13 gets a little bit trickier because it's the cubed root. So you can think, okay, what am I missing to make this a perfect cubed root of x cubed? So we are missing x to the first power, because now I can add those exponents. 2 plus 1 is 3, and the cubed root of x to the third will just be x. Okay, but remember, whatever I do to the denominator, I must do to the numerator. So we get the cubed root of x over the cubed root of x cubed, which is just x, so the cubed root of x over x. Now there is an alternative method to doing this. Some of you might like to put it into fraction form for the exponent. So you might like to change it to x to the 2/3 power and think, what are you missing? So 2/3, we're missing a 1/3. So we have to do it to the top to get it to be x to the first, and then x to the 1/3 over x, which would be the cubed root of x all over x. Okay. This one's the 7th root, so we would first need to break apart the top numerator and the denominator. 7th root of 1 is just 1. The 7th root of a squared, you can think about how many we're missing to make it a perfect 7th root of 7, or just a. What are we missing? We're missing 5 of the a's. So the 7th root of a to the 5th, and then all over a. Okay, we're going to go back up and try number 7 now that we know how to rationalize the denominator. So before we get to the rationalizing the denominator part, we need to flip our first fraction, since it's a negative power, and try to simplify all of our exponents. So go ahead and pause the video, see if you can work on number 7 for a little bit. Okay, so after we simplify it, remember, make it to a positive 3rd power. By flipping the fraction, we can move that 1/2 power, the negative x to the negative 1/2 up to the numerator. Okay, then we're going to apply the exponent, take everything to the 3rd power, and whoops. Then we can multiply straight across. Finally, we've got these two exponent x to the powers. We've got a 1/2 and we've got a 9/4. We need to combine those. So I subtracted the 1/2 from the 9/4, and you get 8x to the 7/4 in the denominator. Here's where you need to rationalize the denominator. So we have 7/4. To make that a whole number as 2, we are missing 1/4. 7/4 plus 1/4 would be 8/4, or just 2. So then whatever you do to the denominator, we've got to do to the numerator as well. So it becomes 5 times the 4th root of x all over 8x squared. Okay, the last thing we haven't covered was scientific notation. These are already done for you, but I just want to remind you how to do this. So you're going to put one number in front of the decimal, and then however many numbers it takes, and then count the decimal